Hello everyone. Now we will do few problems in Poisson distribution. Poisson distribution problems. Read the first problem. I'll read the first problem. A travel company has 2 cars for hiring. The demand for a car on each day is distributed as Poisson variate with the mean is equal to 1.5. Lambda is equal to 1.5 is given. Calculate the proportion of days on which the first one neither cars were used. Neither cars were used. Second one, some demand is refused. Now to do this problem, here is given clearly a travel company has 2 cars. Neither cars were used. Some demand is refused. These two we have to find. A travel company has 2 cars for hiring. The demand of for a car on each day is distributed Poisson variate. Neither cars were used means P of x is equal to 0 we need to find. Some demand is refused. Now when will you refuse? If the 2 cars already hired. If the 2 cars already gone for hiring, then only we can refuse. That means the demand is refused when x goes more than 2. That means P of x greater than 2. Already 2 cars were 2 cars hired. Then only we can refuse the demand. Now that means P of x greater than 2. Then only we can refuse. Now like that we have to find. Now before that first we will write x be the random variable representing the number of demands of car. X is a random variable representing the number of demand for cars. P of x demands in a day. P of x is equal to x demands. How many demands you will get? How many times? Like that. P of x is equal to what is the Poisson variate formula? E to the power of minus lambda into lambda to the power of x by x factorial. This is the formula. Now lambda is equal to given. Lambda is equal to 1.5. Therefore P of x is equal to x is e to the power of minus 1.5 by 1.5 to the power of x by x factorial. Now the first problem we will do. The first one. Neither cars were used. What did I say? Neither cars were used. Neither cars were used. That means P of x is equal to 0. 0 cars. Both cars they did not use both cars. Is equal to e to the power of minus 1.5 into 1.5 to the power of 0 by 0 factorial. If you use the calculator and if you simplify, e to the power of some number to the power of 0 is 1, 0 factorial is 1, e to the power of minus 1.5. E to the power of minus 1.5 value is 0. Use the calculator to do the simplifications. P of neither cars were used value is 0.2231. Now we will do some demand is refused. Second bit is now some demand is second bit is some demand is refused. That when will you refuse the demand? If already the 2 cars were hired, then only we can refuse. That means P of x greater than 2. How can you find P of x greater than 2? 1 minus P of x less than or equal to 2. 1 minus x less than or equal to 2 is P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2. X greater than 2 we can find 1 minus P of x less than or equal to 2. Less than or equal to means 0, 1, 2 because only 2 cards are there. 1 minus, now if you substitute all the values, e to the power of minus 1.5 into 1.5 to the power of 0 by 0 factorial plus e to the power of minus 1.5 into 1.5 to the power of 1 by 1 factorial plus e to the power of minus 1.5 into 1.5 whole square by 2 factorial. And if you do the simplifications, use the formula to the power of 0 is 1 to the power of 1.5 and do the simplifications, you will get 0.19126. Do the simplifications using calculator. You will get the answer as 0.19126. The next problem is the probability of an individual suffering a bad reaction. The probability of an individual suffering a bad reaction from an injection of a certain antibiotic is 0.001. Out of 2000 individuals, find the probability that exactly 3 suffer more than 2 suffer. This is the given question. To do this question, X denote the number of individuals suffering from a bad reaction. How much? N is equal to 2000. N is equal to, let X denote the number of individuals suffering from a bad reaction. N is equal to 2000 and P is equal to 0.001. Certain injection antibiotic is 0.01. P is equal to very small, N is equal to very large. If P is very, very small, N is very, very large, then we have to apply Poisson distribution. Write down. Since N is large and P is very small, we use Poisson distribution. Mean is equal to lambda is equal to NP. Lambda is equal to N, 2000 into P. Since N is very large and P is very small, we use Poisson distribution. Lambda, mean is equal to lambda is equal to NP. Lambda is equal to N into P. How much you will get? N into P is equal to 2. Now, Poisson variate P of X is equal to X is equal to e to the power of minus lambda into lambda to the power of X by X factorial. That is equal to e to the power of minus 2 into 2 to the power of X by X factorial. This is the Poisson PMF of the Poisson distribution. Now the first bit, what we need to find? The first bit is exactly 3 suffer first bit is P of exactly 3 suffer is equal to P of X is equal to 3, that is equal to e to the power of minus 2 into 2 to the power of 3 by 3 factorial. You simplify using the calculator. How much we will get? 0.180447. Second bit is P of more than 2 suffer, more than 2 suffer is equal to P of X greater than 2. P of X greater than 2 is just now we did one problem. 1 minus P of X less than or equal to 2. 1 minus P of X is equal to 0. plus p of x is equal to 1 plus p of x is equal to 2. That is equal to 1 minus e to the power of minus 2 into 2 to the power of 0 by 0 factorial e to the power of minus 2, lambda is 2. 2 to the power of 1 by 1 factorial plus e to the power of minus 2 into 2 to the power of 2 by 2 factorial. That is equal to 1 minus e to the power of minus 2 common, 1 plus 2 plus 2. If you cancel 2 ones are 2 2s are. If you do the simplifications like this, you will get the answer like this. Thank you very much.